Hi guys, I am Darius. I am second year physics student at Bilkent University, and today I am gonna present my modern physics experiment. And before starting to present it, I needed to talk about some concepts because I use them in my project. I will talk about the quantum tunneling. In classical physics, if a particle doesn't have enough energy to cross a barrier, it's reflect back. You can think like that. You throw a rock to the wall and it comes back. But in quantum mechanics, particles also behave like a wave. Because of this wave nature, there is a finite probability that particle can pass through the wall. Pass through the barrier, not a wall. In classical way, you can think that you throw a rock to the wall and it passes through. It sounds weird, but it can be. It's probability very small, but it still can be. This phenomenon is called quantum tunneling. Since quantum tunneling usually happens at the microscopic scales, it's difficult to observe directly. So in our project, we use a classical wave analog called frustrated total internal reflection, or FTR. And I'm gonna talk about our setup, which is relatively simple. We have one microwave transmitter, and which also works as a receiver. We have two prisms which we constructed using wax. Also, there's a simple pendulum. I will talk about the purpose of it later. Experiment works like that. Microwave sends a wave to prisms. Some of the waves reflect, some of them pass through the prisms. When the wave passes through, there's a pendulum behind the prisms, and the wave hits it and reflects back to the receiver. And using oscilloscope, we can measure the intensity of the reflected wave. And if our exception was when the distances between the prisms is increased, we will observe an exponential decay in the intensity. And we see it. For example, when there is 0.3 centimeter gap between the prisms, the intensity was 1400. We couldn't make the gap zero because our prisms weren't perfect. Also, when the gap between the prisms 0.7, the intensity was 550. When the gap between the prisms 1.3 centimeter, the intensity was 330. And after the 1.5 centimeter, our intensity reached a noise level. We couldn't take any useful data after that. Simply, our experiments, in conclusion, our experiments successfully demonstrate a macroscopic analog of quantum tunneling using microwaves and paraffin prisms. We observed the same exponential decay behavior predicted for quantum particles crossing a forbidden barrier. This experiment shows, you can see the plot of the exponential decay. This experiment shows how abstract quantum mechanics can be visualized, tested using classical wave systems. Thank you for watching.